morning, everyone. Welcome back to geometry. Today we are going to be talking about one of the more important things that we're going to cover in this chapter. So for a lot of the chapter, we've been kind of talking about geometry and like this absent blank space, right? No coordinate planes or anything like that. Today, we are going to take some of our geometric concepts and we are going to move them to the coordinate plane. We're going to take them to our next area. And to do that, we are going to talk about two formulas. Our first one is our midpoint formula, and the second one is our distance formula. So by this point, you should all have your note sheets for the midpoint and distance formula. Those should be passed out to you. So if you'll do me a favor, we are going to get ready and get started. We are going to start on the slide that says the midpoint formula. It should be in your top left. So, the midpoint formula for coordinate planes. We talked on Monday about what a midpoint actually was. A midpoint is the point that divides a segment in two. It takes a segment and it divides it in two. Now, in all the problems we've been given so far, we've been straight up given a midpoint to work with. We've been told this is the midpoint. Today we are going to learn how to find it. We have a formula. The coordinates of the midpoint of a segment are the averages of the x-coordinate and the y-coordinates. Okay, the averages of the x-coordinates and the y-coordinates. Oh, and I'm going to color code this just a little here. We're going to use our blue marker for point A. And we're going to say point A has coordinates x1, y1. So those little ones there are just a label. They don't have any value or anything. We're going to say point A is x1, y1. And we're going to say point B is x2, y2. According to our midpoint formula, the midpoint of AB has the coordinates x1 plus x2 divided by 2 for the first coordinate, and then y1 plus y2 also divided by 2. So our general idea for a formula, our general idea is we add the points together, the x-coordinates and the y-coordinates, and then we divide them both by 2. We're going to keep up with this x1, y1 labeling through a lot of today, so make sure that we're comfortable with that. Go ahead and at this point, if you need to pause the video, take a quick second to pause it and finish writing down any notes you need to. Okay, now that we're back, we are going to look at some examples of how this formula works. So, the first example we're going to do is a straightforward application of the midpoint. We're given a segment, and we're told our segment is RS. RS. And it has two endpoints. R is at -1, -3, and S is at 4, 2. And we need to find the midpoint. So first things we want to do first is we want to go ahead and label our points. When we're talking about labeling, the order doesn't matter. Order doesn't matter. So just for the kick of it, we'll call the first point x1, y1. And we'll call the second point x2, y2. Remember, while we can name the points x1, y1, x2, y2 in any way we like, we can't switch the x's and the y's. That's the one thing that can't switch. So let's go ahead and let's plug them into that midpoint formula. Our formula was x1 plus x2 over 2, comma, x2 plus y2, y1, good land, go my land there. Y1 plus y2 over 2. Oh, using our points that were given, that would be 1, that'll be 1 plus 4 over 2, negative 3 plus 2 over 2. All right, so let's go ahead and let's simplify this down. I would always start by adding. Add the top. So if we take 1 plus 4, we're going to get 5 over 2. For the second one, negative 3 plus 2 is going to give us negative 1 over 2. Now, you have a choice here. You can leave your answer like this, or you can do the division. If you did the division, you would get 2.5, negative 1/2, or negative 0.5. Those are your two options that would both work for you. Let's look at another example of this. We're given C as the point negative 4, 3, and we're given D as the point negative 6, 5. Just like before, we start by labeling our points as x1, y1, and x2, y2. So just to switch it up this time, we're going to call D x1, y1, and we are going to call C x2, y2. We can go to our midpoint formula again. So, for the first number, we add the x's together. So I'm going to take my negative 6 plus negative 4 over 2. And then for my second point, I'm going to take my y's and add them together. So that'll be 5 plus 3 over 2. Just like before, we simplify the addition on the top first. We take negative 6 plus negative 4. That's going to give us negative 10 over 2. 5 plus 3 is going to give us 8 over 2. And then here, since we can do some more division, I do want you to do that division. Negative 10 divided by 2 is going to give you negative 5. 8 divided by 2 is going to be 4. And there's our answer. So go ahead and take a second, pause this video, and finish writing down your notes. If you have any questions, feel free to rewind. Okay, let's begin. Let's go back. I've got one more example to work through with this midpoint formula. So, Right now, we've only used the formula going one way. The material we've been given gives us two endpoints, and then we use those endpoints to find our midpoint. However, this can go the opposite way as well. We can be given a different form. And that's what this problem seeks to illustrate. On this problem, we're told something different. We're told our midpoint is 2 over 1. Is 2, 1. And then we only know one endpoint. We only know j as 1, 4. Our task is to find the coordinates of point K, of endpoint K. So the first step I would do is I would write out my information. M is at 2, 1, and J is at 1, 4. Now we don't know where K is, so I'm going to put a question mark for it. The way I like to look at this is I like to compare my x's and my y's. So I want to start with j at 1, 4, and I'm going to compare it to m at 2, 1. Here's the nifty thing about midpoints. Since they're the same distance away, we can use a little trick to avoid some calculation. So if I compare my x coordinates from 1 to 2, if we look between these two numbers, what pattern do we notice? To me, and I'm not looking for anything super in-depth here, I notice that they add 1. To go from 1 to 2, we just add 1. So we can logic that to get to k, we would have to add 1 again. So our k value would be 3. Looking at y, we can take a little bit of a different approach. So this time, as we look at our y, we start at 4, and then we go to 1. If we look at what direction that change goes, this time we're not adding, right? If we go from 4 to 1, we're getting smaller. In fact, we're getting smaller by 3. So we can logic that that change happens again. And to get our second coordinate for k, we decrease by 3. So if I take 1 minus 3, I'm going to end up with negative 2. So our answer would be 3, negative 2. Notice how we did that just by looking for patterns, right? We weren't looking for we weren't setting up an equation or solving anything. We were just working backwards. Okay, at this point, pause the video and take a 7-minute break to work on your midpoint and distance exit ticket. You should be able to do, I believe it's the first 2 or 3 problems. After you do those problems, do not turn it in and wait to finish the video. All right. Now that you're back, we are going to talk about our next big formula. Our next formula is the distance formula. So, just like midpoints, when we've worked with distances in the past, they've been given to us. We've been told such and such is a certain amount of units long, and then we go from there. However, sometimes in geometry, we have to work in a coordinate plane, and we have to calculate the distances for ourselves. Now, here's the T about this formula. This one is long and complicated. So I'm not going to expect you to use it too often. And in fact, I want your calculator to do most of the work for you here. So let's go ahead and let's talk about the distance formula. If you're given a point A that has coordinates, again color coding, x1, y1, and point B has coordinates x2, y2, then the length of our segment is given by the formula d equals the square root. You can find that on just about any calculator. I would recommend not using your phone. This one's a long one, so hang with me. The square root of x2 minus x1, and then you are going to run that quantity squared. That quantity squared plus the second quantity, y2 minus y1. So, what I want you thinking here is x minus x squared plus y minus y squared. And then you're going to take the square root of the whole thing. Now, this is actually rooted in something that we are going to learn later in the class called the Pythagorean theorem. You may have heard of that before. And if so, then this will feel a little bit familiar to you, hopefully. We are going to work a few examples of this. So, at this point, pause the video if you need to finish taking notes, and then we are going to go on to the next slide. Okay. So the good news about the distance formula is that we really only work it one way. We really only work it forward. It's long enough and it's cumbersome enough that going back the other way is a pain in the butt. So let's go ahead and let's look at a couple examples. I've got two for you here. Our first one, we're given the point C at -6, 5, and we're given D at -3, 1. Just like with the midpoint formula, I want you to start by labeling. It does not matter what order you label in. As long as you get your x's with your x's and your y's with the y's, you're going to be okay. In fact, with this one, you even have a little more freedom. But that's okay, as long as you match x's and x's and y's and y's. Okay. We've labeled our points. Now it's time to plug into the formula. So just as a reminder, our formula was d equals the square root, a big old hopping square root of, oh, my apologies, this should be x2, y2. We should have x2 minus x1 squared plus y2 minus y1 squared. Okay, so we can just go ahead and we can start plugging in right away. So equals, our square root carries down, and the way I work this, we take very slow, deliberate steps. So x2 minus x1, that is going to be -3 minus -6 squared plus y2 is going to be 1 minus 5 squared. Okay. I'm going to pull our problem up here so we can keep working. Be equal to, or we take our square root, -3 minus -6. When we subtract a negative, it becomes a positive. So this is actually the same thing as -3 plus 6, which means we're going to have -3 in our parentheses, squared, plus Oh, I apologize. Positive 3 in our parentheses. Making all sorts of silly errors today. And then 1 minus 5. That's going to give us negative 4 squared. Okay. Now that we're at this point, we want to stop and we want to take a second and we want to think, okay, what does it mean to square a number? What does this little 2 mean? To square a number means to multiply by itself. So the example I like to give is 5 squared is equal to 5 times 5, which is 25. That's the classical example I always give. So let's go ahead and let's apply that to our problem here. Equals the square root. So if we take 3 times 3, 3 squared, we're going to end up with 9. If we take negative 4 times negative 4, negative 4 squared, 4 times 4 is 16. Negative 4 times negative 4 is also 16. So we get the square root of 9 plus 16. Our next step is to add inside the square root. So we're going to take 9 plus 16 and we're going to get 25. And then square roots. I don't expect you to do them in your head. I do want you to know how to do them through a calculator though. Once you put that in a calculator, you get the square root of 25 is 5. And that will be our answer. All right, we got a little bit more time, so let's just go with one more example, and then we're going to call this good for today. So for our next example, we are given 2 points, G at negative 5, 4, and H at 2, 6. We can start by labeling again. Just to switch it up, I'm going to go x2, y2, and x1, y1. Okay, so we've got our points. Now we can go ahead and we can plug them into the formula. That beautiful, wonderful distance formula. D equals the square root, one long square root, of x2 minus x1, negative 5 minus 2. Negative 5 minus 2 squared plus, subtracting our y's, we would get 4 minus 6 squared. Okay. Let's go ahead and let's do that math. So, if we take negative 5 minus 2, negative 5, take away 2 more, that is going to leave us with negative 7 squared. And then if I have 4 and I take away 6, 4 minus 6, that is going to give me negative 2 squared. All right, now we need to evaluate the squares. So we need to take negative 7 squared, which is the same thing as 7 times 7. That's going to give us the square root of 49 plus, then if you take 2 times 2 squared, you are going to get 4. So it's going to be 49 plus 4. Which, when you calculate it, is going to give you the square root of 53. This is not a nice number. So you can, in fact, leave your answer like this. Or you can give a decimal. I don't know that decimal off the top of my head, But if I did, I would say it would probably be something like 7.2 or 7.3. We'll call it 7.2. Say that's about 7.2. Okay. At this point, we have talked about distance and we have talked about midpoints. Go ahead and pause this video here to finish taking any notes that you might need. Okay. So, in conclusion, these two formulas, the distance and midpoint, are very helpful in letting us take geometry from an abstract world into the coordinate plane. They give us a couple of really fun, really fascinating tools that we can use. This distance formula in particular will rear its head many more times this year. In fact, it'll come back up tomorrow. So, your job for the rest of class, you should have hopefully a good 30 minutes or so. Your job for the rest of class is to finish your midpoints and distance formula exit ticket. Once you have your exit ticket finished, make sure that you submit it on Big Ideas, and then you take a screenshot and submit that on Canvas for your extra credit point. If you have any questions, I will hopefully be able to be back in the class period at some point soon. And I look forward to seeing all of you again on Friday, if at the very latest. Thank you for your time, and I hope this was helpful.